So moving right along. We know how to do replacement notation. Let's use exactly the same example as before, and let's talk about mapping notation. So mapping notation, because we're dealing with the actual points, remember what we had here. I'm going to get rid of all of this here just to make it kind of clear so that you can see everything all over again. Okay, and let's just quickly do the mapping notation, and let's quickly do the replacement notation. Notice for this one, I took the x and made it x minus 5. So what did that mean? That means I had an h value of positive 5. So describe using mapping notation now. We're going to use mapping notation, how the graphs change. Okay, so every point on the original graph, xy, now gets mapped. H is the horizontal movement of x plus 5. There is no y movement. There's your mapping. Done. That's simple. Take every point of x and add 5 to it. That's it. That's how it works. Look at this one. Remember this guy? Our mapping note, or I should say our replacement notation. See how it's easy to get those confused? Our replacement notation means y becomes y minus 3. But if you remember, that's a k value of positive 3. K values deal with verticals. So now let's use our mapping notation. xy, so every point xy now becomes, x doesn't change, but the y is increased by 3. There's your mapping notation. And last but not least, let's look at the last one here. We said that the x is replaced by x minus 7. The y is replaced by y plus 2. But if you remember, that means that the h value was 7. The k value here was minus 2 because it flipped this sign. Okay, so here we go. Let's write it out here. And a mapping notation, every point, x, y, becomes something different. Horizontally, there's the h, so x plus 7. Vertically, we go down, every y goes down by 2, so that'd be y minus 2. And there is how to do mapping versus replacement notation.